I'm Toni Eberhart. I'm going to be the moderator for today's panel. And hey, what we hope this morning is that you're able to just get a practical view at how, if you're someone who has asked the question, how can I get my hands on some of that good AI, you might be able to do that, at least to have some framework or some tips, tricks, or things that you can bring back to your organization to go ahead and do that. I'm a communication strategist, so I really do hold a passion for emerging technology. I've spent a lot of time in my career working with tech ecosystems, innovation ecosystems. But these folks are really the people who know about AI and have for years brought technical solutions to clients through Booz Allen. So I'm really excited that you're going to have the opportunity to hear from them. So Kuan, Chris, and Doug, just spend a minute or two for the group sharing a little bit about your background as it pertains to AI. Kuan?
Awesome. Well, thank you. Hopefully everyone can hear me. So my background with AI started, I want to say maybe 6 or 7 years ago. And it was, really, I was learning as much as everybody else in the community about the technologies that were out there and the problems that it could solve. So we started very tactically, I would say, with understanding what the algorithms that were out there, everything from natural language processing, computer vision, voice assistance, and applying it to problems that we were seeing our customers were having, whether it was enterprise search-related problems, or object recognition kinds of things. And what was great about it was starting small, right, and training the team and getting them to understand, how to utilize those types of technologies. So I've worked in a variety of different areas: U.S. Postal Service, USPTO, so Patent and Trade Office, some digital engineering AI applications for the Army as well, and have built teams around that and infrastructure related to that.
Thanks. So Chris Shumeyko, everybody. I kind of fell into AI. My degree, PhD in mechanical engineering, where I focused on computational material science, right? Let's use computers to run experiments and do simulations. It's really no different than what we were really doing today in artificial intelligence. But I was working for the Army Research Lab at the time, and this new organization was stood up out of the Pentagon called the Joint AI Center. And one of my directors came to me and said, hey, I need a guy to go do a thing at this thing called the Jake. And I go, great, what's AI? I've never done it. He goes, you'll figure it out. I thought he was kidding, but he was 100% serious. And so 3 days later, I shipped myself up to Carnegie Mellon University to work for the Jake's predictive maintenance team. And I fell into it. And from there, what it was really about is learning what sort of problems can we solve with AI, what can't we solve, but more importantly, how do we do it from a strategic organization kind of perspective, right? Because building a model is one thing, getting a culture to adopt to it is a completely different thing. And that's where I've spent the last 5 or 7 years of my career. After a stint with the Jake, I came over to Booz Allen, and I've continued much of what I was doing there, focused on supply chain, logistics, and predictive maintenance across the defense sector, but more broadly just focused on AI integration across the Army. What does it mean to do AI? Who can you do it with? Where does it work? Where doesn't it? So really excited here to talk to you all today.
Thanks, Chris. I've kind of split my career into two. The first half of my career I spent working for manufacturing companies in automotive, defense, biotech, electronics, just about anything. Worked for a few conglomerate corporations. The biggest problems that we had throughout our global supply chain activities was problem solving. It really was understanding truly what's going on and then trying to figure out, if we make this change, what will be the impact. So we did those things manually. Modeling and simulation activities have been around for a long time. And analytics in its purest form has been around for a long time. So I've always had that bug. I've always had that, let me understand what's really going on here so we can fix it once, rather than having to fix it in multiple different conditions as time goes on. Through all kinds of different machinations in the auto industry. In 2008, I found myself, looking at an economy that wasn't very good when it came to automotive, but there was a lot of consulting firms out there that were looking for people that had a background, and I never thought I'd be a consultant. But I joined Booz Allen in 2009. I've been there ever since. And I started off in the Army account, of all places, on a supply chain activity for a tank program. and then moved into the commercial group where I worked with mostly automotive OEMs on things like automotive cybersecurity, et cetera. And then about 8 years ago, I moved into our CTO office where I started really in earnest bringing on PhD data scientists and engineers and people that understood all of the mathematical calculations that were necessary to run AI and solve problems. And then ever since then, we've grown that practice out. Chris and I are colleagues in that practice. It's one of the fastest growing areas that we see because supply chain is everywhere. And I'm sure you've heard of that. So I look forward to our talk today.
Thanks so much, everyone. Okay, so for me, listening to you each explain your background, the big takeaway is that while AI is a topic that's really in households now about what is it going to do, how is it going to help, how is it going to involve, what are the threats, what do I need to be paying attention to, y'all have been at this for a really long time, decades. And so again, there are processes, there are strategies in place that you all have implemented for clients for decades now that I'm excited to learn from. So I think in order for us to do that, it would be important to kind of level set and get a definition of when we talk about AI, what kind of AI are we talking about? Chris, I looked you up before the panel because when you work for an organization like Booz Allen, there's like 30,000 people, and I know this is going to surprise you, but I have not met other than Kuan, these folks before half an hour ago. So I'm looking Chris up to be like, why is Chris on an AI panel? And I come across an article, and I read a quote that said something along the lines of, AI isn't magic, it's just math, we've been doing it for years. And I thought, well, AI feels like magic, what do you mean it's just math, even though I know it's just math? So Chris, can you start us off, level set, when we talk about AI and when we talk about steps to implementing AI, what do we mean?
Sure, yeah, thanks, Toni. So it's the age-old question, right? What is AI? And I think we've continued to see the percentage of people who can answer that question increase dramatically over the last 3 to 5 years and even in the last 6 months. I think also the number of answers you're gonna get is going to continue to grow and continue to vary, right? You ask one person what AI is, they're going to say, you ask a PhD, they're going to, oh, it's deep learning. What does that mean, right? Or, hey, it's machine learning. Or, no, in its simplest form, it's something else. I think the purpose of just talking through this today is good just to level set our conversation, right? Booz Allen is 30,000, 35,000 people strong, helping clients across defense, civil markets, right? We all have clients that have different needs. So for today, I want to frame AI as this, right? AI is just automating a task usually reserved for a human, right? Take something that a human normally does, whatever it may be, and let's have a computer do it. If we think back to when AI first came onto the market, right, back in the 50s and 60s, we didn't really think of it, we thought of it very differently. Cruise control in your car, autopilot, right? A rules-based system that says if a certain condition is met, then do something else. Cruise control, right? The ignition's on, the car is in drive, the cruise control is engaged. What happens? The car holds a speed until something else happens, right? Very regimented, easy to follow. Today, it's become more magical. And what do I mean, right? And I'm gonna focus on predictions, right? So we can talk about things like computer vision another day or other types of algorithms, next week. But if we're thinking through prediction, right? Your Amazon cart, hey, you happen to have a grill brush in your Amazon cart and, maybe some charcoal, right? You can buy charcoal on Amazon, I've done it before. Then you're getting recommendations for some sort of grill cleaner, maybe even charcoal grills. You're like, what? How the heck did I didn't say any, they're listening to me, right? Hey, they heard me talking to my uncle about wanting to buy a gas grill and all of a sudden no, right? It's taking math to understand and turn an input into an output. So, all those years ago in elementary school, middle school, where you're figuring out equations of a line, you're like, I'm never, ever gonna need this again. Guess what, here it is, right? Linear algebra and this idea that if we wanna relate an input to an output, we use an equation to do it. So, but way back to grade school, y equals mx plus b, right? The slope of a line. In its simplest form, we have an input x, an output y, that are related by m and b, the slope of the line and an intercept. When we think about AI today, imagine just taking that 10, 100, 1,000 times more complicated, right? When you hear people talk about parameters of a model, they're really just things that relate an input to an output, right? We can get much more complicated, we can talk in much more detail, but at the end of the day, it's really just the math that we've learned 10, 20, 30 years ago being implemented in new ways. The thing that's magic about it is we're not talking about, 2 parameters. We're talking about millions, billions, and now trillions of parameters that define how an input relates to an output. That is not something we can comprehend with the mind very easily, and that's where we start to think of it as magic.
Okay, check. Got it. Thank you, Chris. I feel smarter about it already. So now that we have a definition of AI that we can all kind of stick to, Kuan, take us through the steps that you would offer if someone came to you and said, we're ready, it's time, we want to modernize, it's been around for a while. How do we begin to bring AI to our organization? How can I, as an individual, use AI tools to make my day more efficient? What is that framework that you would offer to someone who's curious about how to get started?
Great question, Toni. So we're really going to get back to basics, because at the end of the day, all of this is related to the problem that we are trying to solve. So I will say that step number 1 is understanding the problem, understanding the challenge, and really in a deep domain way, understanding the outcome that you might be expecting from, say, a predictive model. And so it's everything from defining, what those steps are within the problem. What are those opportunities where you could automate a human task? And there's so many great examples now in our homes of how this is done, whether it's through your phone, Google Home, things in your car, right? So there's all these different examples now that you can apply to your problem to say, okay, I could apply an algorithm like that to automate this task. Clarify objectives, I would say, also, and expected outcomes, right? Because while, yes, AI is magic, it does matter, like, what you're expecting the outcome to be, and to manage that a little bit when you're getting started. Because an AI is only as good as sort of your ability to apply it well to the problem. And that does take some iteration and testing and metrics associated with that. Also educating the stakeholders so that objectives are clear, expected outcomes are clear, and the problem that you're solving is also clear to everybody. The worst thing I think that happens is you apply AI to the problem and everybody's coming at it from a different perspective. And they're all expecting things to go a different way, and then they're like, well, the AI didn't work, right? Well, it's not that the AI didn't work, it's that we weren't on the same page of what we were thinking that AI was gonna do. The other thing I would say is readiness. So every organization is not at the same state of readiness to adopt AI, right? And also every problem is also not at the right state of readiness. I would say, especially for prediction models, if that's sort of the realm that we're thinking about, if a human being struggles with the task that you're trying to automate, it's pretty likely that it's going to be a complex thing for an AI to be able to solve that problem, right? So when we think about healthcare applications or any DoD kind of things, one of the themes here is having that human being in the loop or on the loop, I would say, right? Integral to the way that we're solving that problem. So, I think that assessing readiness is critical, and that's everything from the data. So is there sufficient amounts of data? Is the data of a high quality? And do we have evidence that applying a certain methodology to that set of data in a certain way will actually result in the outcome that we're expecting? So all of those things are really important as you're trying to promote adoption anyways in an organization. And then starting small. I think if you are just in the beginning stages, definitely start small and pilot, because you don't want to boil the ocean and fail, and then everybody's frustrated about why we spent so much money on all of this. And so things like natural language processing, think about your business back office processes. There's so many different routine tasks that could be automated. And that's a great way to build culture around this, because you're learning about the technology, and you're seeing the ROI associated with it because you've been able to automate a task within your business operations. So I would say those those are some pretty good first steps to get started.
Okay, I have one go back for you though, because
Yes,
you
ma'am.
said something and my ears perked up, and you said not every problem is ready to be solved with AI. So how do you evaluate whether or not your problem is ready?
That's
Kuan, or if anybody else.
Yeah, well, I can start and then
Yeah.
hand it over to my colleagues. So I would say it depends on, especially if we're thinking, like I like to think about the spectrum of automation to augmentation, right? So if it's something like an Amazon cart, right, that seems like a pretty ready set of data. It's labeled, you understand what you're trying to do. You're trying to associate the purchase of a grill with other things that somebody might want to buy, right? So that's a pretty simplistic problem. If we look at the other end of the spectrum, where we're trying to apply AI now to a very complex, unknown medical diagnosis, that's a lot more complicated. That's not to say that that's not an AI-ready problem, but there's a lot more things that you would need to consider in order to set that up properly from an infrastructure perspective, from a domain specificity perspective, and even maybe creating new algorithms that don't even exist.
Yeah, I think part of the readiness has to come in with the existing manual state. So again, we've talked about the problems. AI isn't about AI. Buying AI isn't going to help unless you're applying it to the right problem. We often say a hammer is a very useful tool unless you're cleaning a window, right? There's a lot of AI out there. I've had clients call and say, I need to do natural language processing. I need to do vision AI. Yes, those technologies are cool, but to what end? And so the readiness factor from my perspective is looking at being ready to use AI, which to me means automation. In order to automate something, it has to be a consistent process. There has to be, if you ask the question of the process, the answer comes back relatively the same. Because if it's not, if there's that variation in there, that will kill the response because other areas will creep in. Think about like Major League Baseball and NFL football. Both have very eccentric rules and long-standing type things. But if you had tried to apply the rules from one to the other, you would get all kinds of bad mix-ups, and that's what we see. People don't do that on purpose. So from a readiness standpoint, crawl, walk, run, do something simple first, step back. We're going to talk about human in the loop in a little bit, but make sure that everything that you're doing in the front end after the data, acquisition and assessments and things like that, make sure that you've applied it to the right context of the problem that you're looking for.
Awesome. I think just thinking through this from a little bit of a different angle, right? Same context as both what Kuan and Doug had said is organizational culture as well, right? Is it may be the right problem to solve now from a technology perspective, right? Hey, it's a new paradigm in space or defense, but the organization isn't ready. And that can mean a whole lot of different things, but when I first think about it, today we have people in K through 12 schools that they can go into Python and build an AI algorithm and a model, and that's awesome, right? But putting a model into a computer and saying, hey, look, I gave you AI is not scalable, sustainable, or stable. And what I mean is, what we're seeing a lot of is models are now a commodity, right? But you have to wrap them in software that people can use and that's adaptable, right? Imagine, hey, grandma can probably use Siri, right? She understands AI and voice recognition. Like, hey, grandma, interact with the model, right? It's not a standard out. She can't do it, right? We have to make sure that there are bounds in place, right? If this organization's gonna, maintain software on their own, they need software engineers, right? They need data governance policies. There's a whole lot more, some of the things that Kuan had highlighted about that readiness, a problem being ready for AI.
Okay, so I'm going to skip ahead, and then I'm going to get back to you, Doug. Chris, so thinking through that process that Kuan just explained to us and some of the discussion about, you've identified the problem, you've qualified it, it seems like something that can be solved with AI. Can you, from your experience, share with us an example of that process working really well? Like, give us some case study that's, hey, here's how we worked with someone, here's how we looked at the problem, maybe we started small, we were able to build off of it. Can you share with us what that looks like in practice?
Yeah, sure. And I think I'm going to stay in the world of supply chain and logistics, but if there's questions that come up that want to take it to a different way, we certainly can. This was probably last year. We had a client an Air Force client that was interested in automating some processes for drawing and technical data reviews. So before you put, a new part, a new system, new piece of software onto an aircraft, a government aircraft, it has to go through a review process for compliance, right? Does the drawing adhere to, or the drawing package, I should say, all of these rules, right? Every note is capitalized, every new part is in red, every old part that's deleted is hatched out, et cetera, et cetera. And you can be looking at anywhere from 60 to 100 rules, if not more, right? And usually what the process is you get a whole bunch of engineers that sit in a room for a week with a giant printout of drawings, and they mark it up in red ink for a week. Those people don't all live in the same city. They all come, they fly together, sit in a city, around a table for a week. So we just paid for all of them to come and do that. We're paying their meals, we're paying for the hotels. They go back, we send the drawings back to the manufacturer, they mark them up, we do it again, right? You may do that 2, 3, 4, 5 times before the change actually makes it on the aircraft. So we said, hey, that's a really ripe process for artificial intelligence. Why? Rules, right? I know that every drawing has to have this part number. I know that every drawing has to have these notes. We can program that really easily. So we met with the client, and we met with the engineer and said, hey, we have this tool that can solve that problem. Let's try it. They go, absolutely not. Go, why? Well, because that's going to take my job. We go, no, it's not, right? Do you really enjoy sitting in a room with your colleagues for a week staring at the same, 4x4 inch of drawing? Like, well, no. Like, cool. We'll take that part away from you, and you get to focus on the fun stuff, right? Talking through the bigger problems that you run into. Like, okay, let's try it. So to Kuan's point, let's try it. So we implemented a solution where we would automatically review these PDF drawings. We had a set of rules, right, programmed into a model that understood, right, still just a computer, those rules. It would review the drawings, mark everything up automatically, and give the drawing set out as an output, now redlined, et cetera. We went through that. We went through the pilot, and we explained to the client, hey, what did you do? And here's what we did. And like, wow, that's actually really cool. And we're like, yeah, great. Hope you enjoyed the pilot. And, 2 or 3 months later, they go, hey, that was cool. Can we do that again? I'm like, what? Like, yeah, we want to do more, right? They had a switch flip in their head that showed the value, right? Had we come to that client and said, hey, give us $15 million and we'll automate this process from start to finish, they would have laughed us out of the room. Instead, we said, let's just take a little bit of a small step forward, right? We'll show you what's possible. If it's not worth it to you, it's not worth it, and that's totally fine. Have a great day. We had fun. But we showed that we're not taking away their job. We're taking away the mundane back office thing that they didn't enjoy doing, right? Instead of spending a week together, right, and sitting in a room around a coffee table or on a conference table, maybe it's now 2 or 3 days. Maybe it's 2 days. Maybe next year or 2 years from now, it's just a day or 2 hours, or maybe you don't come together at all, right? It's not getting rid of their job. It's making them more efficient. And I think that's one of the themes I'd love for you to take away from today is these little problems are about making people more efficient, right? Whether there's a human in the loop or not. It's not about replacing them, making them more efficient.
I love that. The small steps. And I think that over time, those small steps and the tests that we've done have gotten us to where we're at right now, which really feels like an important time for where we're going and where AI will play a role in technology and processes in the future. So now starting to focus on that a little bit, Doug, and knowing that you've been looking at examples like the one Chris just shared for a long time now and seeing those little success stories bubble up. Share with us one, if you've got one. And then I'm also, Doug, can you tell us where you think it's going to lead us? Like, where are these small success stories that it maybe takes a few months to try something, to see some success? But how is that setting the foundation for what we might experience with AI implementations in 5, 10, 15 years?
Yeah, that's a really good question. I think, the one thing, and I will just dovetail off of what Chris was just talking about with the Air Force project that we did, I think the most important thing is to keep the end user in mind. I mean, think about we're here at Space Camp, and all these little trivial things like making sure engineering drawings are correct, making sure that we've got a robust part list, making sure all those things have to be done because they roll up into those little details roll up into major mission activities. So that's why it's critical. So again, AI is nothing more than automation, right? It automates and increases your decision making. So if the AI that you've put in place identifies something, then that's where the human in the loop comes in and says, okay, what are we going to do about that? Where before it could have taken 6 months to do that type of a study, and then someone would have to make the final decision. Now we're seeing it more and more and more in real time. So think about, things like a calculator, for instance. Back in the 1970s, 1980s, calculators were large, they plugged into the wall, and they did 4 basic math functions, and that's it. But it was cool, people liked it. So now we've got mobile phones that have calculators on them. We've got other type activities. It's just throwaway technology in some cases. But without those initial steps, it wouldn't have come to light. And that's the way everything's come from, whether it's automatic dishwashers or anything's toasters. There's sensors involved, there's data collection involved, and there's performance involved. And that's where, kind of, again, we'll talk about human in the loop, but that's all about risk, right? When are you ready to take that step forward? When are you ready in that crawl, walk, run cycle, ready to move out? And some of that is risk tolerance. How much risk can you afford to take here? And that's why with autonomous cars, society's not ready yet. We talked about that. It's just the technology's there, but the society's not ready for it yet. And again, from an autonomous systems perspective, whether we talk about cars that drive themselves and I'm talking about really driving themselves, like you just plug in the destination and it finds its way there. That can happen. But the risk tolerance is still not accepted by the communities at large. So I think the most important thing is as we continue, like large language models is a tool that everybody knows, generative AI. We're seeing more and more companies, embed that sort of technology on phones and get tablets and things like that, where you can quickly summarize a 400-page document into the most salient points. That's just a few years old. And in fact, it was just last year and the year before where we saw a lot of activity at the small business, new startup type companies focusing on what generative could do and what AI, large language models could do. It's something that was very clear to us right away that it was going to become as ubiquitous as using Excel, right? So it's not about, I'm not going to go into a project where I'm going to say, my goal of this project is to use large language models. No, my goal for this is to find out the universe of information in this particular area, and I'm going to use the large language model analysis to do that. So again, that's kind of where we're headed, and that's where we're going to leapfrog. And when we see those risk-tolerable success stories, it just moves the culture, whether it be inside of an organization like Chris was talking about, or whether it be society at large, right? How many people have ever worried that when you stick your key in the car, or when you start your car with the start button, that the tires are going to blow out? Nobody worries about that because it just doesn't happen. That means we've had enough experience to know for ourselves, right? And so the key is to keep trying, keep moving it, document it, respect the rules of math, but also don't try to do everything all at once. So I think where I'm going to see it go in the future, I think that during COVID, a lot of new technologies popped open. That's where DoorDash really kind of came from. There was delivery services and stuff before, but now that technology is there. People trust it. They had to trust it during COVID. Now they don't have to trust it, but they still use it. And the other thing now is that the places like DoorDash and Uber Eats and things like that are starting to look at the technology and the way they offer their services on a competitive landscape, which is going to drive further innovation, which is going to make things even more available for us to use. So I think that's where it is. But you don't go out trying to get to you don't go from 0 to 100. You just can't. Sometimes you get lucky and there's some things accelerate a little faster, but for the most part, you've got to follow the process. You've got to go through and understand what exactly you're trying to do technically from a problem standpoint, and then what's your tolerance to risk. And then the buffer between those is what we call human in the loop, so that the human makes the final decision rather than the AI making the final decision.
Quick audience question. Who is ready to get into a fully autonomous vehicle and go for a ride? Be
Daredevils. We're at the wrong place for that, right?
Be honest. Not enough of you. I'm not doing it. My hand is not raised. I will be the last one.
Can I just tell a quick story? It was
Yes.
2018 or 2019 at the North American Auto Show in Detroit, when several of the OEMs brought out the first editions of their fully autonomous cars. And these cars were like science fiction on the inside. It was just all computer systems, whatever. But they let me ride in the back. And so they had a course laid out at a park. And they just kind of randomly had these mannequins on motorized skateboards that would just shoot out in front of the car. And you know, they didn't tell any of us that they were going to do that. The first thing the car did is slammed on its brakes, absolutely slammed on its brakes. Then a couple of, 10, 50 yards down the road, something else happened. This time, the car kind of hesitated a little bit before it slammed on the brakes. So it sized it up. Then the next thing down the road was a car that would pull out in front. And what they were showing is that the learning algorithms that they put in place were actually working. So the car was learning that, okay, from the laws of physics, that car can't go from 0 to 100, and they're 50 feet away from me, so therefore it's not a big threat. But just to be sure, I'm gonna, pump the brakes a little bit and move forward. That's the logic that they were going through. Again, there's no feelings in any of that kind of stuff. It is gonna do what you program it to do. But also from a learning standpoint, it's like, take in consideration, who would have thought in order for me to calculate whether or not I'm going to hit that car in front of me, distance everybody would guess. But how many people would think about mass and laws of physics and all of those sorts of things? It all gets baked in. How long would it take a person to calculate all of that stuff? They couldn't. So, but in a real life situation, we used to joke and say, if you're driving down the car and down the road in cruise control, and then just for grins, you turn the steering wheel to the left, it'll have some catastrophic results. But if there was an AI on board, it would say, no, sorry, we're going 60 miles an hour, we can't turn left. So you either just had a stroke or there's something very wrong here, and it will shut you down and move you off the side of the road. That's current tech. In the future, it'll just make the other corrections. But again, those little things, and those are huge investment projects in and of themselves. And it's very, very important that they're all done to their completion in order for it to be the right solution at the end.
So I do, and you mentioned about how long would it take for someone to do the calculation, and that kind of brings us back to human in the loop. There are roles to play for machines, and there are roles to play for humans. And so, Kuan, can you talk a little bit, you mentioned earlier, about the difference between a shopping cart making a prediction that you might want salt to go along with the pepper that you're buying, or if you're buying bread at Target that you might also want to have peanut butter and jelly added to your cart because that's what you normally do. Feels like a very low risk algorithm that's been put in place there to predict what the user might want next. But then you also kind of compare that to medical diagnoses, something where getting it wrong is a huge risk. And I'm imagining that in both instances, there is a role for humans to stay involved. And so from your perspective and your expertise, talk to us a little bit about how to keep humans in the loop to the right extent and how to know when those intersections are most critical for the problem you're solving.
So I think fundamentally, if human life is at stake in the decision that you're making, whether it's predicting weather and providing those weather alerts to people and telling them that they need to evacuate from their homes, those are problems that require a human being to make the final decision. I think back to what we were saying earlier, AI is really great at the easy stuff right now. I think it's even like, maybe easy is the wrong word. There are a lot of problems that AI is really good at. And where we get into that augmentation sort of end of the spectrum, again, I think any kind of medical field, any kind of military or intelligence decision around, targets that we're looking at, anything relating to human life, I think fundamentally human beings absolutely need to be involved in that. So I think it just takes, I don't think it's a very complicated issue in terms of when human beings need to be there. But at the same time, I think we need to not be then afraid of applying AI where it's applicable. I think that's the key, right? Because I think we all have that natural instinct to understand what problem still requires a human being. but we need to sort of manage that in the context of still needing to adopt AI and learn from it, because as we think about risks and risk tolerance, we need to understand where the threats in the environment are in order to protect our systems. So we need to be as knowledgeable as possible about the technology and where it applies, and then where a human being needs to step in, we ensure that those domain experts are involved to understand what that outcome is and help to train the AI to get even better. The best examples of those complex problems are when you have domain experts in the mission and the problem that you're trying to solve in those complex areas, combined with a technologist who knows everything about the technology and the infrastructure that you're deploying it in, and that's where magic can happen.
So then, thank you, Kuan. Another way that I'm thinking about this question that, Chris, in your example, you kind of spoke to is sometimes AI implementations make people's jobs easier, and that can also sometimes be hard to accept, that this is going to be good for me. I won't have to work harder. I can work smarter. And I think the worst characterization of that comes from this is going to take my job, like you had said. And especially where processes are very manual, that can be a fear or a curiosity of how this is going to empower and equip someone to work smarter, not harder, be able to do more or to be more informed in their job. And so can you speak to that a little bit, Chris? Doug, I'm also interested in hearing you answer this question because of what you said, and I think specifically your background in manufacturing is interesting to me too. So, Chris, do you mind starting us off with when the good, easy problems for AI that we've already gotten good at solving at, there still can be some resistance there. That's when it starts to feel like magic. What do you mean you can just turn this back office process into an overnight success where we only have to meet for 2 hours instead of a full day? Walk us through that. How can we look at that a little bit differently and be more open or encourage teams that are more closed off to be more open?
Yeah, I think that's a good question. I'd throw it to the audience of how many of you still churn your own butter? Right? I mean, maybe it's a hobby, but technology continues to evolve, right? I think the thing that makes it scary is how quickly it's evolving, right? One of the, a little bit of a story or an anecdote that is really coming to fruition in the last 3 to 6 months, software engineering, right? People thought that this was this protected class of job that would not be touched by something like artificial intelligence. And all of a sudden, you can now prompt a large language model and write a basic application, right? That is fundamentally changing how we think about technology. So when I think about implementation and this fear of taking a job, it's about trust, right? Doug's talked about risk and trust, and this idea of it's not so much about shoving AI down people's throats. I think it's really talking about it's not yes or no. It's a how much or how little. It's a dial, right? Even human in the loop. It's not a single human in the loop, and it's not just a, hey, the human's there or they're not. It's, hey, maybe AI, am feeding you information, right? Imagine you're staring at, 50 news feeds, right? You see the CNN newsroom or whatever it may be, and there's 50 different news feeds. Like, how does somebody actually get any useful information about that, right? Instead, we can use an algorithm that says, well, I'll tell you what, I'll take that 50 and I'll watch them and I'll give you the top 10 kind of anecdotes or nuggets from that. To then, okay, well, you trust me to do it. You've done a good job. AI, has done a good job so far. Well, what if I just start writing a summary for you about everything that's going on? Cool. You're still there, right? You're still going to proofread that summary, make sure it's good, right? The AI isn't delivering the news, but it's all about, this dial of trust and this dial of risk tolerance, back to Doug's point. I think to bring it back to the autonomy conversation, I read a book, so I spent some time at the National Robotics Engineering Center in Pittsburgh, which was where the DARPA Grand Challenge back in the early 2000s developed some of the first self-driving cars. And there's a book that came out and said, taxi drivers fear for their job, right? If all of a sudden we never have a taxi driver again, what do they do with their livelihood? Say, well, what don't we have today that we're going to need? we're going to need a whole bunch of service stations for self-driving cars. There's a whole market there for new jobs and new economies that we haven't thought of. And so I think it's about keeping an open mind, right? You're becoming more efficient, and yes, there may be your job today is going to look different than it did 5 years ago, but that's not a bad thing. That's a good thing. What I do today is very different. I use a large language model every day to make myself more efficient, to proofread, to summarize. I wasn't doing that 5 years ago. It doesn't mean I fear for my job. It's just different. I think, again, start with trust and go from there.
I like that. Doug, what are you thinking?
Well, I'm thinking about my trip to Huntsville. A couple of weeks ago, I said, I live in Detroit, so that's why I'm kind of leaning on being a car guy. But I think when I said, I want to find a flight to Huntsville on this day at this time, and I want to know if there is a available reservation at this favorite restaurant of mine, and I also want to make sure that I get a rental car and all these other things. Go do your magic and present me a package. That can be done in an automated way. Who wants to sit back and call the airline and then call the rental car company and then call the restaurant and then, all those things? It's modern conveniences. The butter churning example is awesome. And so I think, but yet we may be shifting people from one type of a job to another type of a job. So I liken what we're going through with information today to what we went through with mechanics and robots in the 1970s and 80s. Manufacturing locations went from highly manual activities that were paced by the human, right? Largely paced by the human, to a situation now where it's not paced by humans anymore. However, all those people that were operating those machines are still there because they're giving their experience and say, well, this is the way this machine operates. Again, the laws of physics about the way the machines operate is the same. It's just whether you choose to automate them or not. So I think, the acceptance part comes with, in my earlier example about travel, oh, geez, I don't want to do that. Isn't there an app for that somewhere? I'm sure we've all asked that question. I'll bet I can find a way to automate this. And well, just today I discovered that the Microsoft Word on a phone, there's a little button that allows you to change the view to be more customized or more fit to your computer screen or to your phone screen. I didn't know that. I was just reading print view versions of things. And so those types of activities require software testing. They require software development. They require accuracy, and I trust it. I didn't concern that they might have dropped a paragraph by changing those views. I didn't change words around or something like that because I didn't ask it to do that. And I think that as we become more, tolerant of risk or tolerant of what's new and exciting, I mean, all of you, I would say most people in this room, by the time you're moving into retirement and things like that, you will all have had the opportunity to ride in an autonomous vehicle. You will. I'm certain of it. But will that mean that we're ready as a society to just turn them all loose? Right, and again, it's the innovation part that drives it, and the idea. And once that happens, then the entrepreneurs come into play, and they start funding things that might be cool. And if it is cool, it's going to hit. And so, I mean, one of the things on autonomous cars, you think about what autonomous vehicles could do. There's some projections that a smart city using autonomous vehicles is going to save up to 40% of its parking space area. Because what they can do is your autonomous car can drop you at the front door and then go park in a parking lot where the cars are 2 inches apart from one another. Because nobody's getting in and out of those, right? The cars are parking themselves in the best array in a particular area. That means all those 2 inches by every single parking space spot that's out there is free opportunity to put something more productive on it or something. So again, there's all kinds of offshoots from things. It's not just the simple fact of getting from point A to point B. It's all these other convenience type activities. So I think, as we go forward, it's autonomy and automation are going to be the drivers. It's here. Chris was saying, just 5 years ago, you didn't even know what a large language model was. Now, most of us are using it to proofread and to go back and double check, or to go out and see if anybody else is writing on a subject, in a particular area, and you can move it forward. Where before that took a long time, and then you had to, a Google search would only tell you so much. You'd still have to open up the article and read it, right? Where now with a large language model, you'll see on many different programs, including Google, I think, is a summary of what people are saying about it. It's just more information by which you can make decisions. Is it going to rain tomorrow? I better take an umbrella with me. That's simple as that.
Yeah, it's really inspiring to me to think about those possibilities, which feel near future, not distant future, starting with those iterative, small test beds every day, trying something new, whether it's something you encounter in your personal life or implementing something at work that's going to empower a team, is eventually going to lead to a situation where I get to go out to eat and I don't have to worry about who or where my car is parked because it's going to come and get me when we're done. So it's really cool to think about that, and you might have moved the needle a little bit for me personally in getting in an autonomous vehicle, maybe a day sooner. Kuan, I'm going to ask you to round us out here, and then we're going to go through a lightning round. I have some questions for these folks to answer briefly. Just to kind of round out our discussion portion of our time here together, Kuan, can you share with us any kind of last words of wisdom, any things that you want to say, just once again for the audience about if they want to get started, or final advice?
I would say definitely get started. Don't hold back. I would say, we talked a little bit about risk and bias. I would definitely consider, making sure that monitoring risk and monitoring the policies associated with AI is like a continuous living thing. It should be something that's ongoing and just part of the practice. Focus on your culture, focus on training your staff. I think upskilling across the board is critical for not only your organizations, but the clients that you're dealing with, because that partnership and that collaboration is critical. I think we talked a little bit about this just discomfort with AI, right? And people, AI potentially taking jobs and things like that. It is an uncomfortable thing. I think we're in a time where everything is constantly changing, and we do need to be continuous learners in this process. And I think AI is absolutely pushing us in that direction, and we should embrace it.
Thank you, Kuan. Okay, lightning round. So I have 3 questions. One is on the past, one is on the present, and one is on the future. Our question about the past is, what is your favorite AI innovation to date? Doug, kick us off.
I want to go to Huntsville and sit in an aisle seat, and then I want a restaurant. I travel an awful lot, and just those little conveniences, being able to, so I don't need to burden, our administrative staff with those sorts of things. And then, oh, by the way, in places that I go often, now I'm getting things, like I go to Chicago quite often, and I get things, hey, did you hear about the new restaurant in Chicago? I'm getting that from a monitor service that I set up for those sorts of things. That's great. I love that. And I know that it's all powered because they're matching things, and I trust it. I don't go, so why the heck did they recommend that? Oh, it's because you went to these other 3 restaurants at once upon a time, and we thought you might like this too. So that's kind of cool, the little conveniences that take some of the naggingness out of travel. And we've all experienced that, right? And, I'm wary when I get a recommendation that shows me where the nearest laundromat is, however, so I don't know what that's supposed to mean. But no, I think that those little creature comforts, it's important. How many people have a Roomba, a little robotic thing? You've got an autonomous vehicle, okay? You own it. It's there. Your cat might not like it, right? It might be, but it is. It's got the same sensors. It's got a camera. It's got LiDAR. It's got some radar. It's got some other things in it that help to understand what it is. And plus, it learns, right? This is the outline that I did before and things like that. It's fascinating. I did so much. I want to tear it open, but I haven't yet. So.
That's great. Yeah, I agree. Times where technology can bring joy to our life. Yeah. It's just wonderful. Chris, how about you?
Yeah, I'll go a little bit of a technical route, and it changed up my answer from what I had originally said, but I'm going to go with reinforcement learning, right? It's just to get a little bit more technical, right? The concept of let's reward a system as it learns. And the thing that makes that so fascinating is think of us as humans, right? This idea of football or chess, very well-defined rules of the game, but it's up to us to learn how to play it, right? That's what reinforcement learning is at its very core, right? Let the AI learn how to win the game, right? Don't copy what Doug does. Don't copy what I do. Learn on your own. And when you can play the same game hundreds of thousands of millions of times in the span of hours, right? it learns some pretty good strategy. So I think a really just fascinating topic.
Awesome. And Kuan, how about you?
I really have been fascinated with the LLMs, the large language models. So ChatGPT, DALL-E, and all the innovations that it has spurred on as a result, and the applications that you're seeing. Everything from, software development and where it can help there to, just giving me recommendations on where to eat or, whatever question or prompt I'm asking it. It really just has made us all more efficient and has brought a lot of, good things, I think, to our organizations and our homes.
Words of advice to get started. So Kuan, you've already given us some. Chris, I'm going to have you start with an answer on this one.
Yeah. So a little bit of an anecdote, but if you haven't read the last lecture by Randy Pausch, I highly recommend you do. Has nothing to do with AI, but he was a professor of computer science at Carnegie Mellon. And he's telling a story in that book about football, right? And playing football as a kid and learning and having your coach grind on you, right? Practice, practice, practice. And he says something in there, and he says, if you don't get the fundamentals right, the fancy stuff is never going to work, right? You don't try to build this uber complicated AI model or completely transform an organization overnight, right? You have to get the fundamentals right. Understand your data, understand your culture, understand the fundamentals of what AI is and what it isn't before really starting a transformation journey.
I love that. And that's applicable in life beyond AI, but I think it's particularly helpful here. Doug, how about you? What's your advice for getting started today?
Yeah, I think understanding the problem you're trying to solve and the process by which that problem operates. And I think, we've been looking at problem solving in various ways, and go back to my roots in manufacturing, where we try to solve problems over and over again. Well, it's very frustrating when you solve a problem under certain conditions and certain boundaries, but a couple of those conditions change and then the problem represents itself. Your customer still has a problem, right? They don't want to hear that, well, you fixed that, but over here we didn't do this. So there's been tools over the years about variation control. Understanding, the main tenets of the Toyota production system or the lean manufacturing is to control variation and understand that you cannot automate or you cannot improve a process that has non-standard or a lot of variation in the process. It becomes random, right? Those of you in statistical process control and all of these things. So understanding, what's going on in the process, what do we need to commonize in order to automate? Right? Whether it's by putting a robot in place or by putting an AI in place, it doesn't really matter, but understanding those sorts of things. And I think the better handle you get on those things, it falls in line. You can't do the future stuff because that's a foundation. And if you can't commonize the process, then move to the next problem.
Yeah, it really goes back to knowing your problem, knowing it well, and what the processes are that are associated. And Kuan, is there anything else that you'd offer getting started today?
I don't think anything that I haven't said. I would say, definitely start small, pilot, focus on understanding your data, and make sure you have, good quality data, because it's at the heart of every AI problem. And leverage existing tools, right? We don't have to reinvent the wheel. There's a lot of stuff out there to get started, so definitely leverage those first.
Agree. Okay, so I am so excited to ask you this last question because, like we talked about at the beginning of our discussion, 35,000 people at Booz Allen. These three folks were picked to be here to talk about AI because they're excited about it and they know about it. So I have high expectations for how you're going to answer this. I'll be honest with you. What are you most excited about in the future? Give me something good. Like, I want to hear the wild stuff. I want to hear the crunchy stuff. Like, where are we going? What are you excited about? What do you think it's going to look like in the future? And what gets you, like, every single day past these small test beds? It's easy to you because you know it's going to enable this future state. What is it that keeps you going? Kuan.
I am really excited about the intersection of AI and quantum. I think we haven't even seen where quantum computing is going, and had the application to AI and the really large problems. I don't even think we know what problems it's going to solve. So yeah, I'm really excited about the advent of quantum computing and how it will just explode.
So I'd say two things. I think one, agentic workflows, right? So take an LLM and now start tasking other large language models. Take Doug's travel agent problem and say plan my whole vacation, but instead of just giving you an itinerary back, it actually goes and makes the reservation. It buys your plane tickets, right? And that's something we're going to be seeing. We see it today, and it's really here on the horizon. The second, that's a little bit more distant, physical AI, right? This concept of robots today, they're pretty dumb, right? They follow a set of rules. To Doug's, again, manufacturing point, hey, you're going to pick up this bolt, you're going to put it here, you're going to weld this, you're going to do that. Well, now put LLMs on robots, right? Bring large language models, bring the most modern AI models we have and put them in three-dimensional space, right? If it sounds like I'm saying build Terminator, I am not. We're not going to build Skynet, right? But
I heard iRobot.
yeah, right? It just changes the paradigm, right? Imagine your house you come home with groceries in your hand, and you walk in the front door, and a camera sees that you're holding groceries, and it automatically deploys hooks from your wall, right? You've got somewhere to hang your groceries now. The smart house of the future becomes real. So really excited to see what comes out of that field.
Yeah, that would be different and cool, and maybe, I'd be like the last one to have the hooks come out, probably too. Doug, how about you? Round us out.
I think it touches on everything that we've been talking about this whole time. Is that the things that excite me is what we don't even know yet, right? And I think the smart cities, the smart homes, the smart way of doing shopping. I mean, 10, 15 years ago, if I just said, you go on this website called Amazon, and you can buy everything, and then you can have it delivered. And if you don't like it, you just take it back, or you just send it back. And we would have said, nah, that's not the way things work. And I think that's part of the journey that we're on, is that we want more conveniences. We want to make sure, what time is my son's baseball practice tomorrow? And I can never remember everything. Well, now we can put it on a phone. Now we can put it on a watch. So we always know those things. But before, when I was in 9th or 10th grade or something like that, I had this idea for a Palm Pilot. Remember Palm Pilots? And it was a Palm Pilot that fit into the refrigerator door. And when everybody came home, kids, parents alike, they'd tap their Palm Pilot against the one on the refrigerator, and that way the calendar would get synced. I didn't know what I had, right? And now, and that was before the advent of the technical tools that enabled that sort of thing. So I think, finding better, faster ways to do things so that we can enjoy the task, enjoy the work, but also enjoy other parts. And the last thing I'll say is if you look at the way a lot of surgeries are done, it's already robotic. Well, if we can add that technology to diagnosis, to doing things, how much earlier can we get to things so that we can save loved ones or extend their quality of life, et cetera, et cetera, et cetera. And I think, we're right on the cusp of all of that. And again, one of the biggest issues becomes liability. We've talked about this a lot in the auto industry. If you're driving a car, if a person is driving a car and gets into an accident that causes someone else to die, unfortunately, then you've got the person who was driving and they're liable. Away you go. Now think of it as an autonomous car. The litigation still wants to happen, but do you sue the auto company? Did you some scare tactics that came out years ago where that the vehicle was programmed to do that. In a fully autonomous vehicle, they're not programmed to do anything. It's not the rules-based stuff. It's the actual condition spot and understanding what it'll be. We're not ready for that yet as a society. We're just not. And so, but it's going to come. And like I said, the technology is there to have autonomous cars. We just can't get them out there yet. But I'm excited for that part too.
Yeah, I think that idea you had in 9th or 10th grade was foreshadowing. Safe to say you're right where you've always been meant to be.
It was born of laziness, I'll have to say. It was one of those things that I've told you in my game is, I told you in my practices, but I put it on a piece of paper and I lost the piece of paper. So yeah. It's just one of those things.
It's great. Yeah, you're right where you're supposed to be, Doug. Okay, so we've got about 8 or 9 minutes for audience questions, and we have a burning one right there.
Hello. My question is, how do you think AI can help us solve social issues or humanities, like bringing people together or communicating issues more efficiently?
I think when you say we want to change or we want to bring people together, what's the problem we're trying to solve? I mean, there's lots and lots and lots of things there, and we can't boil the ocean and go after everything. I personally believe that with more access to information, taking the time to understand that information, that a lot of misconceptions will be dismissed. Because I think a lot of the stuff that we contend with and we hear about and we talk about gets over politicized. Sometimes it's not. But I think a lot of that is a lack of understanding, or truly an understanding, or truly trying to accept that some of the change I'm not ready for, and it scares me. And so therefore I'm going to be against it for a while. And that's just human nature. It's a fight or flight response type thing. But yeah, I think AI can pull together, common information. I mean, human beings are human beings, right? No matter where they are in the world. And so when I travel to Europe or I travel to Asia, I mean, the motivations are the same. They all have families they want to take care of. They all have livelihoods that they're managing. But what's different? And I'll say that when I started traveling international some 20 years ago now, that I learned a lot. I learned a lot that I thought I already knew. I thought, oh, those people are just different. No, they're not different. They sound different. They may look different, but really what motivates them is the same. So I think, and sorry I got a little lecture-y there, but I think the most important part of any of those sorts of things to me from a societal standpoint is bringing people together and truly understanding.
Just real quick, I think from a more technical perspective too, we're seeing it in the news almost every day. It's getting cheaper to have access to more powerful models, right? And so, and I think I love to teach it. As a professor, having access to information, like Doug was saying, at an earlier age, it's cheap, it's affordable, right? Where even today, not every student is going to have access to a laptop or an iPad. But as the price of compute continues to go down, that becomes more of a reality, right? And so having people have access to these models across the globe will hopefully help push through some of those barriers. I think a more practical example too, to Doug's point about traveling the world, imagine you go to a foreign country and you don't speak the language, but you're wearing something where you instantly do, right? You are speaking that common language. You can understand people and you can see through some of those artificial barriers that have been created. That's something that AI can enable. I think the caveat though is AI can, as quickly as it can help us, it can also create disinformation, misinformation. And I think, one thing I'd meant to say earlier is, as exciting as it is to use these technologies, always remember that we are human, right? Remember how to talk to each other. My partner Chris Milligan and I have talked to a bunch of our software engineers and say, you guys and gals are all brilliant individuals, but please spend some time learning to talk to other people that don't understand the technical, right? Because if all you do is program and program really well, that is still something that can be replaced. Talking to each other cannot. So.
Yeah, I would say, along just to kind of thematically tie all the answers together, I think it's the democratization of the technology and the access to data, and forcing us all to become these continuous learners that's going to tie us all together. Because we're all in this together. We're all learning, regardless of where we are in our journey. And I think that just spurs on innovation and is exciting.
Is AI a particular software package? Is it a particular language that you're writing in? I've heard you mention large language models. That's a poor marketing name, but is that the software? How do you get started fundamentally? Do you go buy licenses for every developer? Does every user that has to have a license? How does it work to get started?
Depends what you're trying to do, right? At the end of the day, you can log into a website and interact with an artificial intelligence model, right? With a model just being, an input that gets you to an output. You can use free software to, have a software engineer or machine learning engineer start to write code, computer code, right? To take your data and transform it and build a model to make a prediction. So it really just depends on what you're trying to do. But at the end of the day, when I speak and talk about AI, it is a model, computer code, that transforms an input into an output or makes a prediction, some sort of, transformation, if you will. You can buy it, you can build it, you can borrow it. It just depends on what it is. It really depends on the problem you're trying to solve.
I would say, generally speaking, as an organization that's trying to modernize their capabilities, I mean, thinking about just basic infrastructure, right? So think about migrating into the cloud. Think about, starting with basic infrastructure modernization before you go into AI. Because if you don't have the right infrastructure and the right access to services and compute and storage, it becomes a very cumbersome implementation. So that's where I would get started.
I think just one thing to think about, we talk about framing the problem. Think about before and after. What's my ideal final result? If I could wave my magic wand and create this result, this is what I'd do. That will help you understand the journey that you have to take. Because it's not a particular software package, it's not anything like that. It's much more of a network, of a web of different things that are interconnected. And I think that you definitely need people who are software developers and know how to do that, high type math and sophisticated math to get those things done. But again, like I said before, a hammer is a very useful tool unless you're cleaning a window. So you just want to make sure that you align it. And we do that with our firm. We're 35,000 people. We've got a lot of people out there working with clients to solve their problem who then turn around and go to our deep technical people and say, we need a way to do this. And they go off and study it and come back and make a proposal on the best way to go after it. But it has to be, here's where I am now, here's where I want to be, what's the best way to get there, and which tech should I choose? You need to pull in experts for that sort of thing.